yes.
Dans la table, faut chercher son default. Tu peux pas sélectionner.
Yes,
pas
1, 2, 1, 2. Can you hear me, Laurent?
Yeah.
Ah, c'est mieux. It is much better.
Much better. Hello, Karsten.
Hello, Karsten.
I think Karsten is just a Zulip user.
A Zulip user. Okay. What is a Zulip?
C'est l'application de chat.
Messaging.
Oh, yes. The chat here. Okay. Hi, Karsten. I mean, she will join you at the time. And hi, Sergio.
Sergio is live.
So, main. How did you do? Every time I'm still.
To do what? D'après le dé, ouais. Tu vas dans les tools, là où il y a les. Ouais, là. Là, tu dis Manage Slides. C'est bon, ça t'est remonté.
Ouais. Et donc là.
C'est bon, donc elles apparaissent, t'as plus qu'à les partager. Tu vois en haut à gauche sous ton nom, là? Ouais, à gauche d'un cran. Voilà.
Ah oui, ok.
Là, tu fais. So Laurent, you have sent him slides. I've seen some slides, right?
Yes, I did some ugly slides in hurry because I saw that you put the topic on the agenda.
And I don't know if I need to join to be seen as in the minutes or if it's just.
You're already there.
I'm here because I'm Zulip.
Yes.
But will that remember me, for the blue sheets? When you're Zulip, you're in the blue sheet. I expect you are. Because I've not joined the.
Yes.
So yes, I mean the chairs are in person.
That is a very special meeting, also in preparation for the next meeting in London.
Right, where the chairs will again be in person, and it's new since the beginning of COVID.
Yes.
So it's been 3 years.
3 years already. Wow.
I guess 2019 and 2022. Right?
Yeah, 2020, 2019.
Well,
yes, because I had
started in 19. So 19 we had the real meeting.
Yes, and I was not there because of the birth of Leona. In July, I was not there.
Well, in fall, I guess we were both there.
Yes.
And then COVID.
And
COVID came in.
Yes.
So that was early 20. So all year 20 there was none. All year 21 there was none. And most of year 22 there was none.
Yes.
So the last time we were together was 3 years ago.
3 years ago.
Third anniversary.
Wow.
And it's like those years did not exist.
Yes.
So we'll be waiting 2 more minutes for the other people to join. Do we have candidates for taking the minutes? Thank you so much.
Thank you, Ivan. Thank you.
I will be taking minutes as well. I see that Anna is not with us, so I don't expect her to take minutes. And Dominic will join late. He said he will be in the second half hour, so we may retain the discussion on the compound hack to the second half hour. Maybe.
Yes. That's very good.
A few more minutes. So yes, today we don't talk about drafts. I mean, our drafts are doing good progress. The big problem we have is architecture. We need to understand which IDs we need, which operations we need for the rules, and that will go to the architecture. And then if there are drafts that are needed, we'll write the drafts. But we need to figure out exactly what we need and how it would work. So it starts with architecture. Which makes it
I think a lot of people from the group will be in London. Maybe it will be great to organize a side meeting to.
Oh, neat.
Discuss.
Yes, I can buy it. So my only concern is that
it will be before the meeting.
Yes, obviously. Yes, we'll talk about that during the meeting today. But yeah, there are a lot of interesting side meetings at this IETF, so we'll have to navigate. That's my only concern. I know sustainability, for instance, will have very interesting meetings on sustainability. But if you care about IoT, you care about energy. If you care about energy, you care about sustainability. So I guess the guys at IETF who worked on IoT could help a lot other groups thinking low energy, because many protocols are not designed for low energy. For instance, protocols which use broadcast, they're not thought for low energy, because if you have to listen to broadcast all the time, you cannot sleep.
Yes.
And if you broadcast, you're consuming a lot of spectrum and a lot of energy and Wi-Fi. So it's sort of thing that the IoT people should, explain to the rest of the IETF, maybe how to design low energy protocols. And with this, let us start.
Yes, Eric.
There is even a table, Eric. 2 chairs and a big table.
So yes, with this, let's get started.
Yes.
I will go ahead with the slides. So hello everyone. This is an interim meeting of the LPWAN working group, with chaired by Pascal and me, so both present, and with the presence of our AD Eric. Hello Eric. It's always a great pleasure to have you. So this is an official IETF meeting, and as such, the IETF policies apply. So by participating, you agree to follow IETF processes and policies, and all these policies apply to you. So this is just the summary, the note well, but you should go and read all the BCPs that are presented here. And typically, in case you're aware of any IPR that is mentioned during the call, you should either abstain presenting that IPR, or should talking about it, or you should go to the chairs after and tell us about it. Of course, everything is written in a much more explicit way in all these BCPs. So, with this being said, so we're taking minutes. So thank you, Ivan, for leading the minute-taking efforts. But of course, we will all be contributing to that. So you have the link here. I'm not sure if Pascal, did you fix the link, because in the No, okay. If you click on the link, it takes you to a different URL. So it takes you to a past.
You need to type 11, make sure it's 11.
Yes, you need to type 11. So I'm going to post in the chat room the correct minute-taking link. So it's here. So the meeting is recorded, and the presence is automatically captured by Meet Echo. I'll take just one minute before moving on. I'd like to ask for approval of the minutes that were taken during the last meeting. So does anyone have any corrections, additions, remarks regarding the minutes that were taken last time and that were put on the data tracker?
I hear no objection.
No objection, so they are approved. So moving on. So for the agenda for today, Pascal, I'm giving you the floor.
We took a little bit more time than usual for the administrative year, because we'll be talking a little bit about IETF-LPWAN-2022, and then we'll move on with the discussion that we started last time. And I guess Laurent will take the lead on that discussion, but basically, we have isolated a number of different issues. Sometimes we need to isolate which device we are talking to, so we can apply the right set of rules. Now, usually a set of rules is common to a good number of devices, which means we need a rule ID, and then which gives us a rule set which applies to a group of devices, but then at some point, there are some values inside those rules which need to be instantiated for a given device, like its IP address. So we need to discuss what is really the device ID for, what is the rule ID for, basically indicating which set of rules, and if the rules evolve, do we need a sequence number in them? And then the rule instantiation. And that's the thing we started discussing. And I know on our side, we have a little bit of IPR on that, using some kind of $sign to replace stuff like the IP of the device. So if you have the device ID, you have his IP. If you have his IP, you can replace the IP in the rule, like, a bash $IP or something. And I know that there might be some IPR in there, but it's kind of a necessary function. So we need to discuss exactly what is needed and how it would work. And so after that, it's going to be AOB. So next slide, if you don't mind.
Yes.
Do you want to take that?
So yes, so we have the She Covers Sigfox working group last call. So Anna is not with us here because she is, she's not here with us here for health reasons. But everything is.
We wish her a good recovery.
Yes.
Fast.
Exactly.
But it's no big. It's okay. Don't worry too much.
Yes. So that's for this part. I think that. So I did not look it up. I'm not going to speak more about this. Anna is going to provide the full overview of what's happening with the working group last call. But it seems to me that everything was fine. On the compound ACK, so I was waiting for the IPR confirmations from the authors. So I have everyone except Laurent that have answered.
Laurent whom?
Laurent Toutain.
Oh, this one.
Unless.
Okay.
Yes?
I will do.
So Laurent, please disclose all the IPR.
I know it will take time because you have a lot, but.
Yes. But that's basically the last part of this.
It's actually two drafts. I have a typo, right? It's the two Sigfox draft.
Yes, the two Sigfox draft. Yes. So yes, Sergio.
Can you hear me? Yes.
Yes.
Just one note in the compound ACK in the Young model. There is some sentences that doesn't fit the page. So I think there's a little bit of the need that says that, but I'm not exactly sure how to fix it. So I don't know if maybe Laurent can help us check that out to see if we can compress that line to fit or do something similar to what they did in the Young model.
Laurent is the expert for it.
Thank you.
Yes, Laurent.
Yes, I am now. I can reduce the lines. I know all the tricks to do that.
Okay,
Thanks.
perfect. Yes, that was from the Shepherd write-up that I wrote, right? I did send it, right? I do. I sent it, and that these are the needs. Okay, thank you.
Yes, Laurent spent 6 months in Amazonia reducing heads, and now he can make the Young model fit in one page.
Yes. So yeah, these were these needs, and you have the name of the in the Young module. Like the name is it's just, how can I say, the way the Young module name is defined, it doesn't match the name within the module itself. It's a small nit, but yeah, you can also fix this one if you're going to fix the length as well.
Yes, and yes, you have to fix both, and that would avoid commands. Having all the ISG members give you the same command is a waste of their time. So please don't worry about increasing the number and resubmitting. Doesn't matter. You have 99 versions if you like. So fix everything and republish. Don't worry about this.
There's just one question that I asked about the chic the compound ACK, and it was not reviewed, but by a Yang. So that there's a specific question about that, and it seems to me that the mod is not big, that it's quite straightforward, and I compiled it. It works, but like in the Shepherd review, it's a specific question, like was it reviewed by a Yang doctor?
You have to say no.
So I said no, but blah blah blah. But I said no.
But Laurent, now you became our biggest expert in Yang. Have you looked at the Yang in the compound ACK? Could you just have a quick glance at it if it's in line with the way you've done stuff in your document?
Sorry?
could you please have a look at the little piece of yarn in the component?
Yes, I will have a look. Yeah.
Yes, just for the spirit, so it reads easier when next to your work. Okay, so that's cool. You're done?
Okay, so that's
so for the SHIC over Sigfox workgroup last call, so it was concluded yesterday, and I got only positive notes, but I must say that it was only from the authors. My impression is the group at large doesn't care too much about Sigfox. We never got many reviews on the Sigfox document. So Eric, it's for you, right? I mean, it's kind of an internal effort between the parties which were interested in Sigfox, which is like a group within the group, and they seem happy with the work they produced. I guess people from the group have read it. They're happy with it, but it's just a subset of the working group, basically. So there is this question, I guess, in the Shepherd, which says, is it like a core team interested? This is typically a core team interested. So, I mean, when you promote this document, Eric, you have to know that it was really the work of a specialized core team inside the work group. Do I make sense?
It does make sense indeed, Pascal. Like pretty much many documents coming out of this working group, right?
No, the other documents, it's still, there is a core team of designers, if you like, but SHIC, for instance, was done.
Yeah, the base document, yes, that's for sure. That was much better. But everything which is linked to a specific, let's say, sub-IP thing.
Yeah, but as it goes, LoRa is, I guess, was raised more of generic interest. And also it was the first one. So I think this problem is exacerbated on the Sigfox, where only really the Sigfox people have contributed. We have to know. We have to mention it.
Yeah, exactly. See it in the Shepherd review and just be honest, right?
Right. I mean, that's it.
There are 6 authors. There are a lot of people involved in the work.
Yes, so that's the core team. Basically, it's the work of 6 people. It's not one, right? So it's good. So it's a group within the group. Yep. So that's pretty much it. So basically, I did not get any opposition, and so if you look at the mailing list, I mean, it should pass. Yes.
Okay. So
present the next slide. So this is the email that I sent. So usually I don't present it, but this time I will. It's my usual email. I just change a thing here and there. As it was, they have changed the agenda link. Now it's agenda without .html. If you try .html, it doesn't work anymore. So it's just agenda. And so we are on November 11th. And that's the very last meeting. So from noon to 1:30. So I hope it's okay with your travel arrangements. I know for Dominique it was a bit tight, but it fits because it's earlier than it was in the first round of the agenda. We have been moved to 12, so it's easier for Dominique to be with us. The usual suspect always expect us to reserve some room for them. Don't expect that. Please look at the dates inside this email. We need to know if you want a slot, and we need to know before the agenda cutoff. So the dates are there. The agenda cutoff is on the 26th, so it would be nice of this month. So it would be nice that you respond by the 25th. So we have 1 day to organize the agenda. We have 1 hour and a half. Considering the work that we have, it should be enough. But please tell us about the work and the discussions you want to have during this meeting. And as usual, you have the questions, draft name, presenter, etc. If you don't have a draft, for things like the ID, the draft will be the architecture. And also, as usual, we have uploaded slide templates. It's already there. So I gave the link of the slide template. And we expect the slides one week in advance. I know it's a wet dream, but we would like to have the slides by November 4, if possible, so we can make the slides available to everybody on the agenda, the IETF slide. And so we're just talking that for the first time in pretty much 3 years, the two chairs will be normally present in London, which is yes.
You could do that.
But Laurent, you're still welcome to sit near the table. So we actually thank Laurent a lot for his help when some of the chairs were not there. But this time, Laurent, you can enjoy your time with less stress. But still, you might be needed again, so stay in the starting box.
Perfect. So then we have the usual.
We have not changed anything there. Right?
Yes.
The status has not changed.
And the advancement, and also.
I'd like to jump on that one. So, no.
Yes. Go ahead.
So first thing is the last line, the shake. You can see it's in the RFC editor queue. So congratulations to the authors and Laurent in particular, obviously, for this work. So now we are waiting for the RFC number. First the editor to fix some things, but then we expect soon to get our new RFC. So Laurent, congrats. Now, if we look at SHIC over NB-IoT, it's a lot of green. I mean, I've rarely seen documents passing so well and so easily through the ISG. So I'm impressed, and congratulations to the authors as well, Edgar, Anna, congrats. That the ISG recognizes it's a very good document, and I expect that it will pass quite quickly, considering all the green that that's here.
And Pascal, if I may interrupt you and to add some more information about the NB-IoT, you have sent a liaison statement to 3GPP, and I don't think we already shared this information with the working group already, and we are waiting for a reply until the 27th Saturday.
I think I mentioned it on the previous interim, Eric, but maybe.
Yes,
better twice than none then.
Yeah, but it's very good. Repeating it's not bad.
It's one of those rare occasions when it's the first time in my life I have to do a liaison statement. So it was like, wow, how do you do that? Thankfully, Eric helped a lot, so that passed. So yes, I mean, SHIC over NB-IoT should be there. So the pieces which quote unquote should be standardized by 3GPP are just informational, when the end-to-end is normative. So only the end-to-end piece is presented as normative in this RFC to come. So this leaves us with the 2 Sigfox draft to promote. And if you look at it after that, it's just the architecture. And actually all the drafts that we had, OEM, etc., they are all like expired. So for now, the big document that we have in our plate is the architecture. And this is actually the introduction for what we're going to discuss next.
Exactly. So with this being said, then I'm switching to Laurent's slides. So
nice preview. So Laurent, could you please enlighten us on what the problem is, which identifier or identifiers we need, and also this problem of replacement, etc., that I kind of hinted in the intro, and the body is yours.
Okay, thank you. So here is not solution, it's just questions. And from implementation we have, and also that comes from the young data model. So I have no solution. I will just put some ideas that I had, and also that they come from the group. So I don't think I can change the slides.
Tu veux le faire? Tu cliques à droite sur le rond. Enfin, dans le coin du rond, tu dois pouvoir. Non. Quelque part en clic. Ou sur le. Non, tu dois pouvoir lui passer.
Okay, so here it's the main idea is that what we have currently is that we have several devices. So we have this star topology, and that's good. I got the control. So we have this star topology, and we we have devices, that's the round box here, and we have a single core that talk with all the devices. And until now, what we said is that we have rules from all these devices that are stored in the rule, but we don't represent it here, and also on the core. Okay, so that's the status we have right now, at least in standardization. So when a device sends a message, it sends it by its rule ID. So the core has first to identify the device to find the appropriate rules, because a rule ID can be viewed differently from every devices. And once he has located the rule, he applies the decompression or the fragment, the assembly, and will send an ICMP-v6 message to an application. And this information, usually dev A is stored on the rule, and application can be something dynamic, but can also be stored on the rule. So one question is, of course, how we are going to identify this rule internally to find which is a good rule. On the opposite, when the core receives an IPv6 packet, so he will look at the destination address. He will get the IPv6 packet. And for example, in OpenShift, what we do is that we look at all the rules, and we find a matching rule because for the destination address match with destination address in rule B. And getting that, we are able to identify who is the owner of this rule, what is the device, and we are able to send a message to that device. So that's how it works in OpenShift. I don't know for other implementations, but it's a way to make the communication in both ways. So what we have said also during talk is that we can imagine a more meshed environment. Here it's not fully meshed. We are still core things that can be identified as core and device that can be identified as devices. But as Carles said in a previous talk, then we can have something more complex, because in fact, when we are in mesh environment, we are not we are not in device and core, and so that's a problem. And I know where now is my copy paste. It was on the side. So what we have to do.
Laurent, just a second. Pascal, he had a question just a minute ago. So
sorry,
yes. Well, that's okay. We didn't want to interrupt. But so basically what you said on the previous slide was like, you identify the rule cutoff because of destination IP. So basically you have a destination IP. Yes. And you said basically what you needed to find now is how to talk to the device, or something like his MAC address. And you have a table somewhere which resolves IP into MAC, like the equivalent of an ND cache, right? Even if it's not used by ND, but I'm looking at the architecture. So I'm trying to figure out component solve, and I figure that there is one component which matches an ID in the IP packet, like the destination IP, into an ID in the LoRa or LPWAN network, like a MAC address. And that table is not part of the rules. It's a resolution.
In OpenShift, it's part of the rule. So,
yeah, but that's architecture. I should not have to say this, right? Because I don't see that's implementation. You have collapsed the ND cache, and that's exactly what I wanted to talk about. So I don't see that the rules should contain the MAC address of the device, because it's not something.
Not the rules that contains the MAC address of the device. It's something above the rules that because you have the set of rules that are defined by.
Speaking, it's a different table. It's like the ND cache.
we can see that's a good point. It's something that is not specified in 8724, and we must maybe not say how it has to be implemented, but we have to say that we need this identifier. And
Exactly.
and
We
the other
need-
problem is,
sure,
for example, currently one problem we have is with the no compression, because when you have no compression means that you have no match, so you cannot find which device has to receive the information. So
well,
that's
if you have an ND cache, which is a separate table from your rules, you don't have this problem. So
Yeah.
it's kind of a problem that you created by yourself if you collapse the two tables, basically.
yes, but on
So
the other end, you need to have a strong. For example, if you match a rule, if you put a mapping between an IPv6 address and in a device address, and that your rules is not the correct one, then here you have trouble. So you have to check the coherency between the rule and this table.
I don't see that it's an issue either, right? Because I'm trying to look at which tables you have. So you have the rule. We said we have something like the ND cache. And now you're telling me you must also have another table which says, for this device ID, it's this rule set. And it's a third table. Because initially you said, I need to have a device ID because for this device, I will have a set of rules.
Yes.
So that you also have another table. I'm trying to look at the architecture again, right? When I do the drawing, I need to show which abstract databases you have. One is the rule itself. You have a number of rules in a table of rules, okay? One is the ND cache. And now you're telling me there must be a table somewhere which says for this device, maybe identified by MAC or something, I have this set of rules. So if you have this table, then you can validate when you get a packet coming in and you match a rule, you can validate. And so basically that gives you the rule. You look at the IP, you get the device ID, you look from the device ID, you get the rule set, and you validate that it's the same. So it's okay, you're good.
Yeah, but in the other direction. And the other direction, what you have is that if you receive to dev B, the message to dev B, so you select here rule B, but if you have a mapping somewhere that says that dev B is the IP address dev B is a device A, then here you have a trouble because you send to the wrong device. So you need this information. I don't know if it has to be on a table. If the table is implicit from the
So when you
rules.
said the other direction, you're saying I'm getting an LP1 packet, an LP1
No,
file.
I'm getting an IPv6 packet.
Oh, so it's the same direction as before. It's coming from the internet.
Yeah.
It has an IP address in it, right? So it says device A, like you said, or you said device B. Okay, so the IP of device B, you look at the ND cache, you find the MAC address of device A. That's what you're telling me.
So I agree that we can imagine ND cache, something dynamic that can be, but what I say is that it has to be coherent.
Yeah, we can check it. But if we have those three tables, we have the rules, we've got the IP to MAC, and we've got the MAC to rule set, we can effectively check, find, validate that the rule that we apply on the incoming packet is actually in the rule set that matches the MAC address. We can validate that. So we are good.
So it's something that, yes, I think it must be in both directions. It means that the rule cannot generate several, if it's the same device, normally can generate only, but to the same IP address, but maybe it's not true all the time. So, but that's something that we
yes, this is, but from what I understand, yes, there is this. So I like very much the idea about the ND cache.
We can abstract it, but it's a table. It's a mapping table.
Exactly, it's a mapping table. Then there needs to be this coherence between the compression rules and that table, right?
Yeah.
But it's
you can validate it. So we can show this flow that Laurent has been talking about. That this moment of times we so the rules, we understand them. We have the Young model, the mapping table between, if the device ID is the MAC, between IP and MAC, it's a generalization of the ND cache. So we understand it. And so the real question we are discussing is, do we need a device ID to index a table to know which rules apply to this device? So that's basically because otherwise we cannot verify.
And another point, that's what I was hesitating, is that a device can be a router. So it means that it can have different elements behind, and so we have to take care. Maybe it works, but we have to take care of that.
Yes. So the point you are saying is, and the way I understood this was, if you apply the rules, maybe you can say, oh, okay, this rule matches. So based just on that, you say, okay.
That's what OpenShift does. But
yes.
my way of looking at it would be, I'm getting a packet. Before I match any rule, I go to my ND cache. I find the device ID. If I don't have a device ID, I'm lost, finished.
Yes.
If I have a device ID, I know this device, I should have rules for him. So I take this table of device ID to rules, I have a set of rules, and I only try to match those rules. They match or they don't match. But I would not match first. I would match after I've found from IP to device to rule set, and look at those rules. That's how I would look at it. So you can never have a rule which matches for the wrong device, because you will only look at the rules which fit the device that you're able to.
And if you want to do a pass-through, where you just have, I mean, you say, okay, well, anything that I don't know, I send to the next router, which can have many neighbors.
When you don't have rules, you don't destroy, right?
Then you need a protocol from the other router to tell this router, hey, I have all these neighbors.
You need a drawing.
We need a drawing. Yes.
But we were talking, for instance, on the Ripple case with Careless. With Ripple, you always have a tunnel to the root. So say you have the LoRa device, you have the first 6LR, which is attached to the LoRa device. And so the LoRa device itself is not Ripple aware, it's a Ripple unaware leaf. It can talk to the first 6LR. The 6LR will take everything he gets, tunnel to the root.
Yes.
So the root will terminate SHIC if first it encapsulates the IP in IP, and inside it's a SHIC packet.
Yes.
So from the tunnel, it knows the 6LR, but not the device. So that's when we need the device ID. So the root can effectively find which device is on the other side of that tunnel, because it knows the 6LR, but not one of the many devices. So the Ripple domain would be exactly like your hub and spoke. You get the root, and through the tunnels, every LPWAN device appears like one hop away, because the tunnel is just Ripple itself is not visible. So we need a device ID, so we know which rules are used to compress. The root will select. That's when it looks exactly what Laurence described. But the device ID needs to be in the packet. Right? Yes. That's my point.
And exactly. And then there is one other question. It is so related to Laurent again, your previous slide. Sorry, I know you want to move further, but so here you put that the IP address is the identifier, but is there a possibility that but then it becomes like a NAT? I mean, if you look at it purely from SHIC perspective, you can have that if you apply SHIC rules. I mean, the way OpenShift works today, theoretically, I think that you can have two devices that have the same IP address and that they only differ in the UDP port. Let's say.
Yeah, so kind of it's like having a PC which has the IP address and it has different USB ports, and the port points to the device.
Yes,
that's why I say the control is not so obvious.
Which you can do if you apply the SHIC compression, but in a ND neighbors table. Basically,
table should have not only the IP but also the port as index, and so you can find the right device ID, I guess.
I think a device can have several addresses, but an address Yes, it can be shared between several devices. Yes, it's
Well,
not easy
that's-
to find.
That's the usual meaning of a port. If you,
Mm.
initially you had serial on a PC, and you could indicate which serial
Which serial.
on the port. For instance, if you do telnet on a certain port, you get on the router, on the port of the router to which you have a modem or something.
Mm.
That's what it was for.
But then it can be that the table has duplicate entries with the same IP address and the same and different devices, and basically that says, well, hey, I mean, any of like this IP address can match to any of these, so you need to apply ship later to discover which one you actually are going to go later on.
Yeah, I know OpenShift works like that. I don't like the idea.
Okay.
I don't like the idea to use the rules as the way to do a resolution.
Hmm.
I think you should resolve which set of rules work for this guy, and then find one rule in that set. So with the ND cache, for instance, take destination IP, it's just one device per IP. Destination IP, device ID rule set. But using the rule set as a discovery mechanism, actually I have a patent that does something like that, but I would not use it there. I'd rather know for sure which set of rules apply first, and then, for instance, if you say the port is significant, then your table, instead of having just ND, you would have ND plus port. I mean,
Yes.
but still have this table. For me, when I was doing SHIC, it was more, Actually, I have a pattern where I use SHIC to route.
Ship to route.
Yeah, because basically, if it's more of a security thing. If you match some SHIC patterns, then you go to the firewall, that sort of thing. So.
Okay, so we have to maybe write something to understand, to discuss about what is a good proposal. And what I was saying is that when we have a mesh network, so here we don't have any more core on the device. We have no more up and down, as Carles states. So, but we can continue to have this notion of up and down, but it will be very limited to some traffic. And so that's why I try to represent here is that we need to identify the rule by an element that will be, let's say, the core, and another element that will be the device. And if we have communication that is symmetric, so here we need to have two identifiers, one for when is the core, and the other the reverse position. And of course, to avoid any confusion, it means that we cannot have the same rule ID in both entry XY and YX. So it was what was described in Ivan's draft. So, and this way we can, I suppose, apply SHIC to a mesh environment.
So just two things. In the architecture, we try to say that there is always a form of transport between A and B. So it could be just PPP, it could be a repo, IP in IP tunnel, but there's always something to transport between A and Y. And that something is created by A or it's created by Y. And we said basically the application is always the guy who creates that thing. So
yes, but we have to identify who plays the role of the core, which will be viewed as what
that's
is
the application.
Yes, but
Yes,
if you look at X and Y, it's here they are quite symmetrical. They exchange in both
they are in terms of layer 3.
And if you have a graph, I think Carles can complement this. But if you have a graph, it was Y take to B, B take to A, and A take to Y. So you are both core and device.
So the way we have done it so far was to say that SHIC is transported into something. can be PPP, can be a tunnel, can be anything.
Yeah, I understand that.
Your TCP session, it could be whatever you like, but someone will start that session. So it's not pure IP over multi-hop. It's always like a point-to-point tunnel.
Yes.
And or transport, and somebody starts that thing. And if
Yes,
we
but
say,
if you have several elements, you can have a loop. In fact, Y can
Doesn't-
be the
for
core
each
of
point-
B, B can be
No.
the core of A, and A can be the core of Y.
doesn't matter. It's all of these point-to-point connections, they live their life. So it doesn't matter if you're the core of X and Y is your core. Doesn't matter. There's no core. There is an application side and the device side. And for each point-to-point connection, the device will be the one that starts the connectivity, that starts the tunnel.
I don't think it works so well because, for example, we don't have source and destination address. We have the dev address and application address.
Yes.
So Carlos wants to say something.
Yes, hello. So yeah, I had like similar questions like the ones that Laurent is now making, and somehow I thought like, well, the way to address all of this is that the endpoints that will communicate need to know in advance whether they will be acting as dev or app. In some cases, perhaps there are like different relationships here, like different interactions, like node B maybe is in one role when talking to A, but on a different role when talking to Y. So perhaps one option is that the nodes need to know in advance somehow which will be their role when talking to each one of the other potential endpoints. And also perhaps consistently with this, the rules should be written accordingly so that the nodes should know in advance which are the roles when talking to each specific endpoint.
Yeah, that's if you want to do chic flat over the mesh. But if you establish a transport layer like I don't know, UDP between A and Y, if for instance the overall have a daemon waiting for some connection like this, or it could be PPP, it could be anything. As soon as you wrap chic into something and somebody has to start this something, then you know who started it, and it's the application, it's the device.
No, I disagree because it's not the position is not who starts. For example,
It's not initially, but
if you have chic over IP, you just receive a packet, but you have to know, do the other guy act as a core or do the other guy act as a device?
That's why I'm saying you don't do chic over IP because you would have that problem. You do chic over a session. You need to have a point-to-point session between devices, and you do it inside the session. And when you start the session, that makes you the device.
But we for example, if we do it over 6LoW or over IP, we don't have this notion of session.
So two cases. First, if your network has one, then you don't have a problem, right? Repo, there is a root, so you always know which one is. When you have a real mesh, basically two devices who talk, they need to know they have to talk. And basically, it's not just random X talking to random Y. There needs to be a reason why X and Y talk. And they need to kind of know that they will do shit together of some form. And so my suggestion for the case where you don't effectively have something like repo to say who's the root is that you expect that there is a session. When you're saying you don't have a session, I say if you don't have a session, we're screwed. So that's why we need to have a session.
Carlos has something to say.
Yeah, sorry. So if I may, I think that perhaps in some cases it's possible to know in advance who is going to start communication, but perhaps not always.
No, I'm not saying you need to know, but somebody will start it. And once somebody has started it, whether it's A and Y, I don't care. But the guy who starts it plays the role of the device. So as soon as you have the same,
the rules need to be written beforehand, right? So once you know which will be the role for each device, So I'm not sure that this would match like all the
Well,
cases.
Carles, sorry, but yes, the rule needs to be written in advance. But maybe the IP address of A and the IP address of Y should not be written at the time you write those rules. It should be saying $device and $application. And once you decide to play those rules between A and Y, then you would reply, and the session is started by A, meaning is the device. Then in every rule, you should replace $device by A and $app by Y. But it can only be done once you have decided who plays the role of device and who plays the role of application. Because effectively, otherwise we're in a loop. I agree with you. If you write the rules such that A is the device, then A has to be the device. If you know in advance and you force A to start the session, well, all good. But if you don't know who will start the session, then you can only instantiate the rules once you have started the session. So that's why we had in the title, we had this concept of instantiation. So basically the rule set should be the exact same. All those devices are equivalent, right? They're all the same. So the rules for A to talk to Y or A to talk to X or A to talk to W should be the same. But for one thing, the name of A and the name of W inside, like their IP address, inside those rules. But otherwise the rules should be the same. So we should not have 1,000 set of rules flying in a network. We should have a single set of rules where A and Y and W, etc., so application and device, are empty things that you have to fill, basically like a form.
No, for me, that's an optimization. It's
just one point, because I see the time running, and actually I remember that in the past we discussed quite a lot the question of what are the different problems that come from this mapping of like up and down to up and dev. I don't seem to recall what were all the issues with, because there were issues if you do that in a very naive way, let's say. But I think that it's not an unsurmountable problem, right? So I think that we need to have a session specifically on that. Have like a small. I mean, here we have this general presentation, and it's like I think that we can get lost. So maybe at the in London at the IETF we can meet and just say, okay, well, what was the issue with that? So what were the points?
We need the whiteboard, right?
We need a whiteboard. It's
not the main meeting. So
yes, we need.
That would be a subject for said meeting.
Exactly. To go over the.
I agree. Can I have 2 seconds for the next two topics? And I will not explain. Just so the other topic was to then, if you want to provision a core with rules, so it's to find a way to identify it. And I think Pascal made a very nice comment last time, because here we don't have to identify the device, but we have to identify the rule, and we have to take care also of privacy in that part. And the last point is about security. And I think it's a funny thing, because if you look at a young data model, in fact, you can give read-only or write-only to some leaves in a model. So for example, here I say that all the leaves concerning the field ID are writable, and the other, I don't know, we can specify also for them. But in fact, when we will have a chic rule, it's not what we want. For example, here, I will say, I don't want a device to change the destination address on the core. For example, it could be a way to do a DOS attack, because you take control of plenty of devices, and you ask the core to target a specific host, and then you flood the network with that. So what we have to say in our rule is, this part is read-only, or this part is read-write, and the device can manage it. But it's not by leaves, it's really by type of fields that we have to do it. So it means that we will have to extend what's the control done by the young data model.
Because what you just said, if I understand well, is the young data model, if you allow to change destination address, you will allow it for all rules, not just for this particular.
Yes, because it works in column, and here we have to work in row. It means that we have to, for example, to protect this specific line where the field ID is 99 and 98, 59 and 58.
Okay, so that's actually I mean that's actually an excellent point. I'd say that maybe we need to ask to the young guys, because I would be very surprised that we are the first ones having this kind of problematic, and to ask them, hey, have you seen that? So if they have seen it, how did you solve it?
Yeah, and it's not only to say, I mean, I have a column which says if it's read-only or not. I mean, you should have a way to enforce it. For instance, say we distribute those rules. So some fields are read-write, some fields, so they are mutable basically, and some fields are not mutable. And the rule set should be signed so that the non-mutable fields can be validated, because you will distribute the rule, right? If you have this big mesh.
So now that you have it by type, you can say that's read-only, but you cannot say it as Laurent said.
Prove. I'm in a mesh. And basically what I want is have a single rule set, because I will flood the mesh with it. Otherwise, we need to download
Pascal,
rules to have.
just one point. This is an optimization. It's a way to simplify the fact that each device has its own rules. But the basic model is each device has its own rule, and we have some ways to make it the same and change just few things. But the basic model is...
The optimization is the $IP being replaced by your IP address. But the fact that in a given rule set, some fields are not mutable, do we have a way to prove it by crypto that when you get the rule set, they are the original?
So I like the Alex approach, because when you write a young data model, you say this leaf is readable and readable or writable. You have a model that can allow you to control that, but maybe there is a way to say when we can allow rewriting only if the value of this leaf is this, and this. But I am not so. I have no answer to that.
Yes, are two things.
There is one more point also here. It's identity, so authentication. Who has the right? Because I mean, you can say that this is writable, but maybe then you need to say who has the right to write it. I mean, we can say, well, it's everyone, and no, like it's either it's a constant or everyone can write it. So like that's a simplification.
Oh yeah. So normally what I wrote in the security issue is that only the device can modify its rule and cannot modify the other ones. But even if a device can modify everything in a rule, it can be a vector of attack. And so we have to take care of that.
So when you download the rule, my question remains, right? When you download the rule, there are mutable fields and non-mutable fields. Yang will say which one are mutable and which one are not, but it will not prove that it was not hacked. So if everybody obeys the rules, yes, you will only mutate the mutatable fields. But my question from the beginning is, how do I know that nobody has tampered it? Because it's not because it's written read-write that it is read-write. I mean, somebody sends the bits you want, right?
Yes, actually, you have two things. One is the values that are there, and this is like you get it from somewhere. Well, are you sure that that's really the thing? So that's the first thing. And then once you have it installed, then it becomes live. Let's say the OpenShift. Someone sends a message, hey, well, change that value. You have then you have the access control. Then you have that, well, hey, but who are you? You need to do the authentication part, and okay, then I can apply this access control so that I can actually control. Is it? Oh no, you cannot touch that. Sorry, the data mod. So the specific profile says you cannot. You don't have the right to change that, or you do have.
Yes.
But that's a separate thing. Then the point that you're saying is, how do I trust the thing that I got?
Yeah, just like when you download an image from open source, you have a shard. You have the hash for it.
But that's the beauty of CBOR, and is that when you do a hash of things, it's similar. You don't have a white space, or identification that makes that if you do a hash, you have the same JSON form, but it represents in different ways. Here we have something that is easy to sign after. So if we have a way to define how we say what is writable and what is readable, and we trust the guy that signed, I think we solve the problem.
Okay, so that's another topic. That sounds very interesting. So, folks,
I mean, the question the way I was asking it, Laurent, is: do we sign only the non-mutable fields, or do we sign every field mutable and not mutable? Because maybe some fields make sense.
What you can sign here, you have a CBOR structure, and you sign this CBOR structure.
That means that you also sign the mutable fields. So as soon as they're mutated, you cannot validate tuples anymore.
No, that's different. Here, it's, for example, you get your rule from a repository, and then you apply it. So what you have to authenticate is, this is the rule I have to apply. And inside the rule, you have now change this by an IP address, but that's another stuff.
That piece works.
So to answer your question, you can actually solve the part where you can have the mutable fields, you replace them with 0. The non-mutable, you keep them, then you do your signature, and then you see that, okay, well, that's
what IP does. I mean, for instance, when you do IPsec, and we have Eric with us, but basically the idea is you zero out the mutable fields, and that's what you compute. For instance, the flow label is mutable. And even if the IP standard says, or those drafts, they say, you write this or write that or don't touch it, there is no way to validate if it was not touched off or at all, because it's never signed. Right? So they just, okay. We are at the end of the hour.
We're at the end of the hour. Super interesting discussions and very promising for London. I hope to see you all there, because it's going to be a good place to be, I guess.
Yeah, so we need to look at which rooms. I don't know when they are made available, to book. Basically, to side rooms, but we will need to book one, and it depends on everybody's travel. So, all the guys who are interested in that discussion, please let us know about your travel arrangements, because we have this constraint to book that room pretty much near the meeting, because people won't be there for the whole week.
Yes.
So we need to look at Thursday or Friday, I guess. That's available on those days.
Yes.
Okay.
Okay. So, thank you very much, everyone. Thank you.
Thank you very much, Laurent. Bye-bye.
Bye.
Thank you.